Alright guys, welcome to my first video. This video starts our next unit, which is our weather and climate unit. This video titled Greenhouse Effect and Heat Transfer. Okay, so let's start with a brief review. So we know that we get all of our energy from the sun via radiation. Radiation is just the transfer of energy from the electromagnetic waves, so haha, yay, bringing back the electromagnetic spectrum. And the sun is the primary energy source that drives heat transfer from the earth. Make sure you pause this and get it written down. Remember that it's because of the sun that we have everything that we need. Remember, photosynthesis, sun drives our water cycle. I mean, everything happens because of the sun. So let's take a look at this awesome picture. What this picture is showing us is that the sun's energy is able to pass through the atmosphere, which is right here. Oh, you can't see that. Let's see if we can make that work. Nope, still not working. Okay, so thank y'all for bearing with me. Alright, so you can see that the sun's energy is passing through the atmosphere, and when it does that, it doesn't really cause it to warm up that much. Most of the energy is actually absorbed into the Earth's surface. Okay, when it's absorbed into the Earth's surface, the land and the water, then it's able to heat up a little. Okay, so the radiated heat from the surface is trapped in the atmosphere. So that it warms the air, and then once the air is all warmed up, then some of that energy is going to end up being transferred back out of the atmosphere. And you can see that some of it makes it out, some of it makes it in. Okay. So what's cool about the Earth is a Goldilocks planet. So think about Goldilocks and the Three Bears. Okay, it's not too cold, not too hot, but it's just right for life. So when we talk about this greenhouse effect, it's what's occurring naturally, and it's actually a necessity for trapping the right amount of heat for life on the Earth. And our greenhouse gases, which includes carbon dioxide and methane, they all keep the heat in our atmosphere. So this trapped heat directly impacts Earth's temperature, which will have a direct impact on our climate and our weather. So global warming is supposed to be this nice gradual increase in the Earth's atmospheric temperature due to the increase of the carbon dioxide and other greenhouse gases. But unfortunately, because humans are causing this to happen a lot quicker, because we have things like our chlorofluorocarbons, CFCs, all the exhaust from our awesome engines, power plants that are giving off greenhouse gases, deforestation, getting rid of the forest, not being able to get all the oxygen and everything like that. And so all this, it just builds up. And warmer Earth means changes in our rainfall patterns, rising sea levels, and who else knows what other kinds of crazy impacts on life as we know it. Okay, now let's go on to heat transfer. Now I know I'm going a lot quicker than the normal videos you're used to, but remember, you can hit pause anytime you need to, rewind anytime you need to. So what heat transfer is the transfer of thermal energy from one substance to another, which we talked about in great detail at the beginning of the year. What you need to make sure you remember is that heat is always transferred from a warmer substance to a cooler substance, and it's transferred in 3 different ways: via conduction, convection, and radiation. So when you think about conduction, I want you to think about when you were younger, hopefully you were younger when this happened, and you touched the stove for the first time and were like, ow, that's hot, okay, because the heat was conducted from the stove to your fingers whenever you touched it. When you think of convection, I want you to think about how, especially if you've ever been to a 2-story house, how it can be a lot colder in one area, a lot hotter in one area, the whole concept of how heat rises. And then when you think about radiation, of course, think of the beautiful sunshine and that heat radiating towards us. Okay, so I definitely encourage you to try and print out some of these pictures if you get the chance to. But this comic strip shows great examples of radiation, conduction, and convection. When the guy's like, hey Duke, doesn't the fire feel good? He can feel the transfer of the heat through the electromagnetic waves. Doesn't require matter to transfer thermal energy, which is how we're able to get the radiating heat from the sun. Okay, conduction requires direct contact between particles of matter for heat transfer to occur, which is why his hand is burning when he touches the poker. Convection occurs in fluids and air. Heat rises because it's less dense. Cooler air falls back towards the heat source because it's more dense, and these currents cause uneven heating, which is why in the picture he's going to turn on the fan because all the heat has risen to the top. Okay, and last but not least, guys, take a look at this picture. You can see conduction in the handle, convection in the water, and radiation from